Hello and welcome back to compiler programming. In the last video, I made this exception handler work. So now if we try to run the tests, then we will see that we are printing this RIP. The reason it happens twice is because we add exception handler in every function. And I think we need to figure out how to limit it to one. One option would be to just exit process at this point in time. But I don't know if that's the right thing to do. Probably it is. I don't know. We'll figure out. For now, I don't care if it is happening twice as long as it's happening. So what is RIP? And RIP is relative instruction pointers. This is actual pointing to the actual byte of the instruction that failed. And I believe it is pointing to the start of that instruction, which is good and bad for us. You will see why later. But the idea for today, and I would consider it successful, if we manage to print the location in file where this instruction is happening. And this will require us to make a few changes. In particular, right now, we do not have a good mapping between instructions and their locations in output bytes, in output code. So we do have a mapping between instructions and their location in code. So if we go to here and we go to instruction, then you can see that there is actually both the compiler location and the source location, which is extremely handy. I'm not sure we will be outputting compiler source because compiler source is more of a internal thing where user should never see that we crashed, I don't know, in value.c line whatever, because they shouldn't care who outputted the instruction, but it is helpful for internal debugging. What is important to the user is the location in the source, and that should also be there, so we should be able to look it up. However, we don't really know what is how to correspond basically this RIP offset to particular instructions, and this would require sort of a multi-stage lookup. The first thing would be it will involve us actually which is probably what we would start with, is getting this function table entry and trying to go through the unwind information to get to something that we will need. And that something we'll need is also something we will add right now that is not there yet. If we look at the structure of this, so we have, let me maybe make it nicer, define max count of codes and means info max count of codes for stack, and that's 2. So I'm just trying to make it nicer to read this stuff, because we will have problems otherwise. And I think now that I'm looking at it, and now that I see that we do need to align these things, it might be possible to actually not do this +2 and go back to the version that I was doing before, that I used exception handler directly. I'm sure I want to. The whole situation is unwinded, so I think I will do some refactoring and cleanup, because it has this very awkward, variadic length of the struct, and it's not very easy to work with in C. So I'm not sure how to best do that. Okay, let's go with this for now, and I will just say it like this. And info exception handler size in unbind codes. The whole thing, by the way, also needs to be aligned, which is something that we need to do. Okay. So maybe I do need to use that weird expression. Anyhow, that is all for later. And are we still building? We are. And this is our union for exception handler, right? And afterwards, we have exception data. So there we can shove whatever we want. So let's do that. And what we will put in there is just, this is only going to work in JIT mode. That's all the exception stuff right now. But we will put the pointer to the function builder. And that should allow us to get to the instructions if we want to. So let's do that. Let me put here fix me actually turn this into a variadic struct with getter functions, something like this. But for now, I can say that, okay, it has to be 32, U32 aligned, I guess. Although I don't think it matters, but whatever, our pointer is 64 bits anyway, so it's fine. Well, let's just do function builder star builder. This is what is gonna be in there, and you have no idea what function builder is, so let's help you with that. In reality, we can actually move this stuff just below because it doesn't really matter that it's here. Okay, let's try to run the tests because we changed the definition and want to make sure the alignment still works out. Everything seems to be fine, so we can continue to try to actually put stuff in there. So what we will do is now we'll say unbind info builder. I wonder if I should keep the name the same though. It's fine like this. Is builder. Okay. Seems to be fine that we added a bit more data in there. Now the fun part is we need to look up this function and MSD RTL lookup function entry. This is what we want, right? So in here, ideally, we should be able to get the function entry from this relative pointer. So control PC, let's see. I don't remember if it's absolute or relative. So let's look at what the documentation says. The virtual address of an instruction bundle within the function. I wonder what instruction bundle means. So returns now. Can be 0, I think. It's just the speed up thing, but I think I can just pass 0 there. I don't care about the speed. Like if we get to the exception handler, we are crashing anyway, and it doesn't matter if it takes forever to print the stack trace. Image base. Oof. This is a bit tricky. What do we have in here? SDN context. So what is here? A bunch of homes, whatever. And I think there is absolutely no description about anything in here, which is, extremely great. So I know what these things mean. These are registers. I think some of them are for maybe for ARM, but last branch. I don't think we can get it from here. So let's look at other things that we get into. What is establisher frame? So let's just get information about exception handler and exception handler. Where are you? Exception handling, language specific handler. It's called exception routine. Can I do that? Exception handling routines. That is not exactly what I was looking for. That sounds fine. Yeah, the point about this, okay, actually tell us something. So it's a pointer to an exception record, which has a standard Win64 definition. Okay, where is your standard Win64 definition? Exception record. So this is going to be useful to print out, like we should convert this to a string and use it to know what actually happened. Exception address, exception information. Yeah, I don't think that here we also have anything useful. Our problem right now is I'm not exactly certain where to get the image base of this whole thing, right? Because to look up the function, I need to pass something here, but I don't know how to get that. And that is very interesting to me. So there is this establisher frame. What is that? Is the address of the base of the fixed stack allocation for this function. I don't think that is very useful. I mean, it will be useful later if we actually do stack unwinding, but it's not what I'm interested in. Aha, we actually get the image base. Good. Is the image base address of the module to be added to 32%? Okay, yeah, okay. Yes, great. So dispatcher context actually contains what we want. And we can say U64 image base is dispatcher context image base. So we can put this stuff here. And I guess is the value of rip within the function. Okay, so I basically, this contains, we already get the runtime function, but what am I doing? So I don't even need to look up anything, it all is given to me. So I can just do dispatcher context and function and entry, right? This is what it's called. Yep. Great. This is what we want, and I think it even has this handler data. So I would like to do the following. Function builder star builder is dispatcher context handler data. And right now, how would I check that it's correct? I guess the easiest would be to just break there with a debugger and see if that's correct. Void of builder. Okay, we want value C, right? Yeah, and program end. So let's try to break here and see what's going on. Okay, we were able to break. Now the question is builder something that is remotely correct? It does not look to be what I want. So either I screwed up putting it there, so this stuff here, or it is not what I think it is. Points to language specific handler data for this function. It should be the right thing, I guess. Context, oh, that's what I want. Exception record. Exception record. Let's check the stuff here again. Yeah, so exception data. It's called handler data here, it's called exception data. Is it the same thing though? And do I need to do anything special to say how big it is or something? Find info, variable. Yeah, they don't say anything specific here about how this works. So this will make it actually over aligned right now, but that should be fine because we are just pointing to those things. Yeah, this should be okay. The question is, oh yeah, that is not, again, it's the same stuff as with previous one. That's not correct. So let's do this. Define and info exception data size in unbind codes. And let's do this here, size of U32 divided by size of unbind code. And here would be size of void star divided by size of unbind code. Okay, so something like this, and also like this. Now we need to go back to this stuff and fix this thing. So what I'm gonna do is I'm gonna take U32 or function builder star exception data is exception handler address +1, and then we need to cast that to void star. Let's do void star. And then I probably don't need the cast. So what I'm doing here, if you're not very familiar with pointer arithmetic, basically this is pointing right after all of our unwind codes that are aligned to be even number. And so we write out that exception address, and then we are, for the next thing that we're gonna write, we just need to move by 32 bits that we used to write the exception handler address, and this +1 is basically doing that. It's moving by the size of this. I'm not a big fan of how C does it, but that's basically standard way to do it. So I guess we're doing it that way. I do want to figure out a better way to manage this whole situation. I think I want specialized functions for dealing with this unwind info. Okay, so let's rebuild and let's try again and see if we have better luck now with what builder is. And it is still very much borked. So all of these things are not what I want. Let's look at this stuff. So builder is pointing. I wonder if it is actually star and not star. So like this is a pointer to that handler data. And probably that's exactly what it is. So value C, what if we make you into a pointer? Locals. Well, that is sort of better in some sense, but not really great. So it's saying that it is null. I'm still not 100% convinced that this is exactly the same thing that we are writing out here. So let's try to look at it ourselves. And what I'm gonna do, let's check again what is available to us inside of this nice record language handler. So this is basically a pointer to ourselves. Record, runtime function. Okay, so let's, I guess we can get to it from here as well. So we have dispatcher context, function entry, unwind data. Okay. And bind info star. Info is function. I already forgot what it's called. It's called unwind info address. Info address plus so let's put your context image base something like that. Okay, let's see what we have now. That seems reasonable, I guess. The address seems like something correct. I think that will work. So now what we should do, so what is count of codes? So count of codes is 1. That means that we need to say unwind codes plus 4. Let's just make this formula here correctly. So we start with saying that what's the type of it? U8, right? So we say U64 offset handler data offset is info count of codes. We will do U64 align 2 plus this stuff, right? And now we can say that we don't need this anymore. Function builder, say function builder star. Builder is so we say info and find code plus handler data offset, and all of that cast to a pointer, and that should be our builder if everything is like I think it is. And we still have completely incorrect thing. So what is handler data set? That seems correct, right? Because we have one, here we have one code, and that code says that we it's basically this stuff, right? Code offset, and operation info. What we can do is we can go to the thing that actually produces this and compare. I guess I can say printf %lu /n and exception data rest. So actually it's better as lx. cu64. I need to stop this. So now we should be able to compare them. I'm breaking on the wrong thing now. Okay. So this is where we put the two handlers. Let me make sure it's in the screen. And here's what we have. And that does not look right at all. 66812228. And this is where we are looking right now. So it is there anything that is remotely in that area at all? So if I look in the context record and look at REAP, it is nowhere near this. This is very, very curious. Oh, I'm doing really, I think I'm doing a really bad thing here. Yeah, this is actually wrong. So again, this is void star, and this needs to be function builder star, because we need to put the pointer in there, not the yeah, it's interesting that this didn't explode horribly somehow. Actually, no, why would it? We were just yeah. Okay, it was really wrong. We were just overwriting these variables and being very happy with that. So now we need to so now they should be correct. And that also might be whether we see that dispatcher context handler data is actually what we want. So it is at 40 and it's probably this one. And let's see if builder is better. Builder is not really better. But here it might be that again it is actually star star again, but let's just look into here, and I will do it right now. So function builder star star handler data. Aha, so yeah, I messed it up there, and we don't need to do anything funky. I will leave this stuff here just in case whether if we do need to get to the function definition for some reason, but now everything seems to be fine. Okay, we have the builder, which is very, very neat. We can continue to, let me edit to git index so it's not lost. Maybe I can actually commit this. Deep head, let's look at what we have. Yeah, I don't mind committing this. Commit. So 101, oh, 111, a very nice number. Add function builder address as exception handler data in JIT. Okay, that is cool. Now that means that we are ready to proceed. And to proceed, now we know the offset inside of the function, inside of the function machine code. But as I said, we can't really map it back to the instructions because instructions have variable width, and we need that information to be able to find this out. So we have two options. Option number one, which saves a little bit of memory, but is a bit more complicated, is to basically re-encode all the instructions again until we hit the right offset, and this will give us the right instruction. Option number two, which I think is better because long term we will need something like that anyway, I think, is to attach the size of the encoded instructions onto that instruction. So let's do that. And that should allow us to do what we want. So for that, we'll need to go here. We need to go to the instruction. It's here. And what we will do is we'll just say U8 in encoded byte size. Something like that. Now we'll go into here. And the way we're gonna measure this is we're gonna go all the way to the top, and let's check what's happening here. Okay, here there is nothing really about instruction, so we can just say like this. So it doesn't really have a size because it was labeled, but let's make sure that it's 0. And in here, let's say 64. Original buffer length is buffer memory occupied, right? And now let's go to the end. So this is when we encoded the instruction, right? This is success pass. We say instruction encoded byte size. Here we would say U64 to U8, so that the response checking, and it will be buffer memory occupied minus buffer or original buffer length, right? Something like that. Oh, I always mess it up. It's just buffer occupied, and here's just buffer occupied. Okay. So now we should know what is the size of the instructions. And that means that if we take the program counter, whatever, control PC is the value of rip within the function. I guess I need to subtract target IP. No. So I'm just thinking how to get the offset within the function. So let's start with that. We have control PC. I think control PC was also somewhere else. I know that was an argument to the other thing. Okay. Here, right? No. Exception address. Dispatcher context. Okay, whatever. We'll take this one. And let's first print it. So I'm sure that this is what I think it is. Dispatcher context control PC. This is no longer required. Yeah, so this looks like a valid rip pointer. So if we take that thing and subtract image base, and subtract so we do actually want this because we can subtract the start of the function. What is it called again? MSDN runtime function. That is really, really unhelpful. Okay. It's called begin address. So this should give us the offset within that function. That does not look like offset within that function. Address of the start of the function. Oh, because that is supposed to be like this. Let's do it that way. U64 absolute function begin address. How about that? Okay, this seems like something that is even remotely correct. So now that we have this address, and we have a builder. Let me do it like this, so it is just more comfortable to work with. And for U64, I is 0, I is less than of builder instructions. And we also have in U64 current offset is 0. And we are saying now that if current offset is the same as so we need now to extract this stuff, U64 relative byte instruction byte offset is this stuff. So if they are the same, then I want to print the instruction, and I think there is a way to do that. I should totally extract this into a separate function, but for now, I'm gonna do this. Value C, and I can say instruction star instruction is so we get the instruction. This is gonna be a pointer now. That seems fine, and here we just do current offset plus instruction encoded byte size. Yeah, we need to change this stuff because I'm passing it here by value, and that's not gonna work if I want to actually change it. Good that I noticed it, or I would be very debugging it for a while, I guess. Okay. I'm so looking forward not typing all these arrows when I can use my own language. So encode instruction. Now it needs to be like this. Result of the expression not used. Value. Okay. Plus equals. That was a good warning from the debugger or from the compiler. Well, I guess let's see what's going on. We'll break in here and look at this stuff. I don't need to break in here anymore. We start with this. Let's look at our relative. So it should be 10. I think I read the instructions or something. Function and code. Yeah, no. You're no longer destroying this array because we actually need it. No, let's just ignore this. We should not be destroying it. It's fine to keep it till the end, even in when we are building the whole executable, because if we run out of memory, this will just swap and we don't care. So let's try that again. Can I get instructions now? I can. First of all, let's take a look if we have the encoded size. So we have 5-byte instruction. Offset is not the same. We are adding offset. Good. Now our offset is 5. We have next instruction. What is the size of this instruction? It is 4 bytes. Wait, 1-byte instruction? I don't think we have that. So it's a bit suspicious to me that this relative instruction byte offset is 10. Maybe I'm doing something wrong here, but looks to be correct. Okay, let's just see. Question is what is your size? Your size is 2. And what are you? Move. Okay, let me remind myself what is the actual code that we are dealing with. So this is the thing that explodes, right? And in particular, it is this stuff that causes the problem. So I would expect, you know what? Let's verify this like very precisely. So we will go here and go here. We'll go to this assembly. We'll go inside here, go inside here. And so why does it say 10? 10 does not make any sense whatsoever. So either I screw up by giving it the wrong begin address in the first place, or I'm not even sure what else could it be. So let's just put this stuff somewhere so we can watch. This was which debugging I did. So this is the function offset, right? And neat trick I realized I can do is I can put comments into here. So this would be like function begin address, right? And then this is where we expect to exception or reap. Exception reap. So let's just see if that is actually what is happening. Okay, F5. Good. now we can start actually comparing. Function entry, dispatcher control PC. So it looks like control PC is after the instruction after all. So it points to the end of it. Okay, it's not a problem. The problem is, why do we get weird absolute function begin address? Actually, we get it correctly. Very confusingly. So absolute begin address is indeed 6C. So these are the same. But this stuff is 10. It's already gone. I want to look at this stuff again. Is it 10? Oh, it's hex 10, so it's actually 16. Duh. I missed that part. So it's actually 16, and 16 should make sense. So we have 4, we have 5, we have another 4, so that's 13. Yeah, okay. All right. Now everything is fine. The only problem is we need to check for the offsets after the instruction. Let's do just that. So here, let's write a comment. Let's go provides instruction pointer after the instruction cause that caused the exception. That also would explain why Visual Studio, for example, shows really weird, like why Visual Studio shows the next statement when it crashes. So we add instruction byte size before comparing. Okay, let's see if that is working. Well, let's just run the tests, and if everything is fine and I didn't mess up somewhere location, because there are a few instructions without locations, then everything should be amazingly great. And look at that beauty. That's actually very interesting. So it actually gives us a stack trace, right? Even though I didn't think it would, but it kind of does, because first address that we get is this one, and second address is this one. So I don't even need to do anything. This is a stack trace, which is beautiful. The only thing we are missing right now is sort of referring to the function name, for example, or outputting nicely the actual source code or whatever, but the whole pretty printing of source code information is a separate thing altogether. It has nothing to do with this stuff. So I thought we would only get just one thing and we have to unwind stack ourselves, but it looks like we don't need to. Everything is great. Obviously, right now we are catching the exception here, but in real code, we will not. So it will just crash afterwards. And this is really cool. I kind of like it. That is more than what I wanted to do for the day. We have the information, we can show it up, and it's very, very neat. I'm looking forward to extending this, but the whole idea why, let me talk a bit, why am I going in this direction at all, right? Why do I want these things? Well, first of all, stack traces are useful in general, right? But additionally, I was thinking that after I spent a bunch of time looking at the PDB file format, and then I saw a few streams from Jonathan Blow, who is working on, just like last few days working on the dwarf and code view information and all this jazz, and it's so painful and annoying that I started to wonder why do that at all, right? And why not make the compiler your debugger as well? Because a compiler has even more information that you can put into these standardized formats. Like it has actually full information about everything in your program. So that's just something that I thought would be neat. And this is sort of the beginnings of it, right? In JIT mode, we can just get this information very easily. It should be possible to do it with the compiled executable as well, right? But right now I'm not interested in that. I will consider the JIT mode be the debug mode because I think it's super neat. And like now, once you make an executable, then I suppose that everything is fine. And if that doesn't turn out to be the case, and if I want to do something more, then well, I'll do it later. For now, this is super neat. I will obviously work a bit on enhancing the output, making it look nicer and so on and so forth, but this is quite boring code. If you do want to follow it up, just you can follow the repository. I will link it again in the description below. But that's it for today. I'm super happy with the results, and hopefully you'll join me next time when I work on something new. Goodbye.